Hello everyone, welcome to Introduction to the Machine Learning class. In this class you will learn about the mathematics briefly that work behind the machine learning algorithm. You will learn coding and deploying the algorithm to use in the real world simultaneously. If you want to understand more about the mathematics, I can give you the optimization technique book that's easy to learn by yourself. So why the machine learning so popular and the most exciting technologies today? The figures show the various applications of the machine learning all around you. This is the autonomous drive vehicles, automatic robot, and the cooking robot, the remote sensing, the medical diagnostics, okay, this is me. The object detection and recognition, the face detection, and the crack detection, the object classification. The AI try to learn and mimics how the human brain learn and get better and better. And finally, it can do better than human. Google DeepMind AlphaGo win over GoMaster, and Deep Blue, IBM Deep Blue that beat over the chess champion. If you notice that, here, the artificial intelligence and the machine learning is not the new technologies, and why it's very popular today. One reason is about the powerful PC and embedded systems are available now that allow us handle with the big data input and use the algorithm on the real times. What the difference of the AI, machine learning, and the deep learning? AI or artificial intelligence is a technique that enables the computer to mimic the human brain behavior. The machine learning, the technique that gives the computer ability to learn without being precisely programmed to do so. And the deep learning, the subset of the machine learning, the computation of the multi-layer neural network feasible. What is the machine learning? Someone who gives the interested definition of the machine learning, the fields of the study that give the computer ability to learn without being precisely programmed. That's great. And later that, Tom Mitchell, who give more modern definition to us. A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance that task in T as the measure by P improve with the experience E. What does that mean? Does that mean the machine can learn from the experience by itself? The machine learning can categorize into two types. The first one, the supervised learning algorithm. The second one, the unsupervised learning algorithm. And the last one, the reinforced learning algorithm. Supervised learning algorithm. Supervised learning algorithm problems are categorized into the regression problems and the classification problems. You give the data set to train the data And the data set is just like apples, the picture of apples. And we should give the correct answer to the machine. The machine will learn from that. The regression problem, we're trying to predict the continued output. The continued output, yes. For example, we try to predict price of house. When we know the some parameter of house, just like the area of house in the square meter. Or we try to predict the age from a picture of the person. Okay, if we like the graph like this. Okay, this is the graph like this. This is the area of a house, or we may call it feature. In the meter square, we may call it feature. Feature is the type of the parameters, and this is price, the output. Give the data from it, and we fit it by the linear function like this. We may call it our model. Okay, like this. For classification problem, we're trying to predict the discrete function. Yes, discrete function. For example, we give the body temperature and we try to predict who infect or not infect the COVID-19. Okay, just like this. And we write the graph again. We give the temperature, the body temperature here, and this our output infect or not. Give the data like this and this, and we figure out this function, and we will know who infect or not. Okay, that is the discrete output. Find the input of the data composed of the dataset, and they already know what our correct outputs, namely label. Label is correct answer that we use it to the input. Okay, the message, we use the output as the input. Okay, you may call all of them is a training set. Unsupervised learning. Unsupervised learning we can categorize into two problems, clustering problem and non-clustering problems. Here, for unsupervised learning, we don't need the correct answer to input or the label anymore. This is because the machine can clustering the data based on the relationship among the variables in the data. For example, for the unsupervised learnings, example is the cocktails party algorithm. That is like this. Okay, for example, you want to identify individual voice and the music background at the cocktail party. That is unsupervised learnings. Reinforced learning. Reinforced learning needs the feedback from the output and allow the machine learning learn the mistake from it. Okay. For examples, the dog action. If the dog action so well, we will give the reward to it, and it adapt the behavior. Okay, that is the reinforced learning. In this class, we will talk about supervised learning algorithm only. Okay. This, the picture, the comparison about the traditional programming here. Okay, sorry. Traditional programming and the machine learning algorithm here. Okay, the traditional programming, we input it with the data as input, and we program it just like the codings and give it condition how to program its work, and we got the output here. Okay, analyze the machine learning algorithm. We input the data input like this, and we input the correct data output or our answer or our label. To the machine learning, and the machine learning give us the program, or we may call it the hypothesis function like this. That's okay. We will feed our hypothesis function into the input of the traditional programming, and we get the output. And then we don't need to explicit programming anymore. That is the concept of the machine learning. The dataset. We can divide the dataset into the dataset for tuning parameters, maybe for small data, about 60% of all data, and the big data around 98% of all data. And the test set here, the test set for evaluated model, or the depth set for model selection. Okay, the learning process like this. We input the training data into our algorithm or our model like this, and the models will give us the hypothesis function, and we use the hypothesis function to predict the size of house or the size of flat, and we will get the estimated price. Okay, thank you. For the next video, we will talk about the regression problems.